So yesterday we did talk about subnetting. In which we saw how we can subnet to different networks when we have 1.0 network with a /24. You can say that we can use some of the formulas that we have. The first formula can be number of networks, and that can say that if we convert it into binary. Now those who didn't understand subnetting yesterday, they can also pay attention while I'm reviewing the Class C subnetting standards over here. So the first step is for you to understand that how you can convert the CIDR value into binary value. So as you have the CIDR mentioned as /24, you can write down the binary value of it as you have 24 ones. These are our 8s. I'll separate them with a dot. These are another 8s, and then these are the last 8s that you have. And then you will see 0, 0, 0, 0, 0, 0, 0, 0. So you can say that the range that you have, this one is for network prefix, and then you can say this one is for host prefix. Correct? Now this is default scheme. We haven't divided anything from the host prefixes. So whenever we kind of convert the I would say the bits from host octet to network prefix, then we say that these bits would be assumed as borrowed bits. Otherwise, they will not be considered as borrowed bits so far because they are still there and we are just using the default scheme that is available there. Cool. So let's say that we haven't borrowed anything, and what's going to be number of network over here? It's going to be 2 to the power 0 because number of network is nothing but 2 to the power number of borrowed bits, which means the bits that have been converted from host bits to network bits. I hope my voice is clear and loud. And then this would be 2 to the power 0. That gives you an answer as 120. That gives you an answer as 0. 1 itself. 2 to the power 0 is 1. And then you figure out the second thing, that is number of hosts. And you can say number of hosts is going to be how many bits do you have as 0, and these are 8 bits, correct? So you can say 2 to the power number of bits, and that's going to be 2 to the power 8, and you get 256 as the answer, correct? And as we start our IP address with 0, we are going to end up at 255, but the number of usable, or I would say valid host, is always going to be 256 minus 2, and this 256 is nothing but number of hosts. So you need to figure that out. And then the third part is going to be subnet mask. And subnet mask, we just figure that subnet mask out by just converting the number of on bits, or I would say the CIDR value, into dotted decimal. Cool. So it's going to be 255.255.255.0. Correct. So this makes our first 8 bits. The second octet provides our second octet or second 8 bits, and the third octet provides the third 8 bits, and the last 0 represents the last 8 zeros that you have. Then the fourth range is going to be figured out for block size, or we can call it as the ranges. So you can say that the ranges are going to, of course, start from 1.0, where the first network is going to start at 192.168.1.0, and it will go till 192.168.1.255. Do you understand that? So that's exactly because we need 256 IP address in one network. So we start at 1.0 and we end up at 1.255. Since we start at 0, we end up at 255 and cannot go till 256. Perfect. So that's /24 at our end. Okay. And then I hope it's cool and clear. Then we will just try and do /25 just beneath it so that it's easy for you to compare both the subnets and see what the differences are. So let's say we go 192.168.1.0/25. This is what we are seeing. And if we compare the /25 into binary, it's gonna be, these are going to be our 24 bits. And then out of, I would say, the last 8 bits, that is, these are our host prefixes, right? We are going to borrow 1 bit for the 25th bit that you see over here for /25. So what we are going to do, we are going to convert the first 0 of the last octet into 1, correct? And remaining 7 are going to be the part of host prefix. So you can say that this is still host, and then this is network. And this bit acts as our borrowed bits. Do you understand that? So when we again come up with number of, I would say, network, then we specify the 2 to the power number of on bit, that's 1, which is this bit. Then the answer is 2 over there. Then for second, we specify what is going to be the value for host, and that's 2 to the power 7, correct? Because we have 7 zeros over here, and that gives us 128. So you see how the division is done over here? Totally in Class C, you are just going to have a network of 256 each time you do any kind of subnetting. You cannot have a network that is bigger than 256 in Class C. So, like whatsoever you do with the subnetting, the network is just going to be divided by some value that would be in the power of 2, okay, to get some smaller part of the network. So earlier we had a big network of 256. Then we are dividing it into 2. Okay, so we make parts of 256 divided by number of network, that is 2. And that gives us 128. Correct? So we make two networks of 128 hosts. If we divide it by 4, you're gonna get a 4 network of 64 hosts. That's how it works in Class C. Okay, and as the value of CIDR changes, the things changes as well. So currently we are going to get two networks, okay, and then we are going to get 128 hosts in each of that particular network. Makes sense? And out of which the valid host is equal to 126. Sorry, 126. And the third thing that you need to figure out is subnet mask. And subnet mask is going to be the dotted decimal conversion of this value, which is 255 for the first octet, dot 255 for the second octet, dot 255 for the third octet. And then as you have this 1 bit on, you need to consider the master formula that we use: 128, 64, 32, 16, 8, 4, 2, and 1. Out of this, there is just first bit that is on, which is this. If it is 11000000, then first 2 bits. So you compare 128 plus 64. If it's 3 bits on, then you take the first three values of your, I would say, master formula. But as there is just 1 bit that is on currently, we are just going to consider that, and the last part will come up as 128. That's how the subnet will come up. And then the fourth thing will be block size. And block size is going to be 192. The first network is going to start at 192.168.1.0 and is going to end up at 192.168.1.127 because we are going to have 128 hosts in each network. So we start at 0 and end up at 127. And then the second network is going to start at 192.168.1.128 and it's going to end up at 192.168.1.255. This is our network number 1. That's our network number 2. The first IP address are going to be network ID and the last IP address are going to be broadcast ID. Make sense to you? Any questions over here? This is the easiest way that you do subnetting with you. Subnet mask will be same for all the networks that you use. Valid host count differs on the type of subnetting that you're doing. If it's /25, then the value of course will change. But you just need to mention that the number of hosts will keep on changing as you keep on changing the subnet. Okay, so the valid host is always going to be number of hosts -2. Cool. Then we will move ahead with the next part and we will try to also see how /26 and /27 works so that you can understand and get more familiar with it. So we will move ahead with 192.168.1.0/26. Okay, the things that we need to focus are network, then you need to figure out host, then you need to figure out subnet mask, and then you need to figure out block size. Cool. So these are the things that you need to do. Again, following the drill, what do we need? What do we do at the first time? We write down the master formula, that is 128, 64, 32, 16, 8, 4, 2, and 1. This is your master formula. Then you convert this /26 into binary bits. That's going to be 11111111. This is 16. This is 24. And then you borrow 2 bits from the host, that makes it 26, and then you write down the remaining 6 bits as the host. Okay, and these two are going to be network, which is going to be borrowed. Cool. So the number of network becomes 2 to the power 2 over here. That gives you 4 networks, and the host becomes 2 to the power 6, which are these. That becomes 64 hosts, and the valid is equal to 62. Correct? Then the subnet mask for this becomes 255.255.255 dot. It's going to be first 2 bit. That means 128 plus 64. Okay, that gets 192. And the block size are going to be 4 different networks. So the first network starts at 192.168.1.0 and it ends up at 192.168.1.63. The second network starts at 192.168.1.64 and it ends up at 192.168.1.127. The third network starts at 192.168.1.128 and it ends up at 192.168.1.159. The fourth one starts at 192.168. Okay, this is kind of a wrong value that I have mentioned. It ends up at 191. Cool. Adding 64 into 128. And then the next one will start at 192 and it will end up at 192.168.1.255. These will be your 4 networks. Okay, that's how you work with /26. Moving ahead, we will move with slash 27, and let's say that's 192.168.1.0 slash 27, and in which we will figure out the binary is going to be this is the last example from class C that we're going to have. And then we will say our 3 bits will be borrowed 25, 26, 27, and then 28, 29, 30, 31, 32. So I will write them as cool. These are going to be host, and these are going to be network. So the first thing that you figure out is network. The second thing is going to be hosts. The third thing is going to be subnet mask. And the fourth thing is going to be ranges or block size, whatever you call them. The number of network is going to be 2 to the power 3 over here because of the 3 bits that you have, that makes it 8. The host is going to be 2 to the power 5, that makes it 32. The subnet mask is 2 to the power, 255, 255, 255, 3 bits. That means 128, 64, and 32. That makes it 224. And the ranges are from 1.0 to 1.31, 1.32 to 1.63, 1.64 to 1.95, 1.96 to 1.127. That's how you come up with the first 4 networks. The second 4 network would be 1.128 to 1.159, 1.160 to 1.191, 1.192 to 1.223, 1.224 to 1.255. That's what the thing was. All these would be network IDs, and all these would be broadcast IDs. Do you understand that? That's how you come up with the slash 27 subnet. Okay, so I hope you understand the subnetting. Now there is this one catch that you need to understand. Whenever you kind of see a slash 31 network and slash 32 network, we don't really use them in Class C subnetting, because if we go with 192.168.1.0 slash 31, what you will get is, if you convert it into binary, 1 2 3 4 5 6 7 8 9 10, 8.1111111, 1 2 3 4 5 6, and then you get 0 0. So when you have only, you don't get 0 0, you get 1 and only 1 0. So what you have over here is just 1 bit off for host. So that makes number of network is 2 to the power 7, which is 128, and number of host becomes 2 to the power 1, which is just 2. So you can see that the valid host cannot be in, as one is going to be network ID and the other one is going to be broadcast ID. So that's why we don't really use, I would say, slash 31. And in 32 as well, there won't be any bit that would be reserved for number of hosts. So it's going to be just one IP address that will be used. So that's why we don't use slash 31 and 32. And we only use till slash 30. In slash 30, what you get is 2 to the power 6 as number of hosts. That gives you, number of network. And as host, you get 2 to the power 2 as 4 IP address, and valid IPs would be 2. And where will you use these two? Whenever you connect a router with another router, you can use this one IP address on this end and the other one as this end. So they both can talk with each other and communicate with each other by staying into the same network. That's why we call it as point to point subnet. Make sense? We call it as point to point subnet over here. So that's what the content was for slash 30. And then we will go into class B subnetting now. In class B subnetting, the range will be from /16 to /23. And let's say that we take an IP address of class B that is 172.16.0.0 and we do subnetting for /23. So what do we do for the first time? We just write down the binary scheme and also the master formula that we use. Correct? So you say 11111111. That's 8 bits. That's 16 bits. And this is default N and default N. And what are we going to do? As it has all like the 16 bits reserved for, it is determined based on the network prefixes that are allocated. Okay, if we talk about class A has a network prefix of N, 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 and H. Sorry, class A has a network prefix of N, H, H, and H. Class B has N, N, H, H. So 2 octets for network and 2 octets for host. That means that /16 is always going to be dedicated, okay, for network. And how much you can do modify in it? You can go and turn on all the bits of, or I would say less than 1 bit of third octet. So that goes till /23. As soon as it becomes /24, you are jumping into class C. That's why we have said that class B has a range of /16 to /23. Cool. And if we specify the host prefixes that you have, those are going to be 0, 0, 0, 0, 0, 0, 0, 0, 0. Do you understand that? This is going to be network. This is again going to be network. Then this is going to be host. And this is also going to be host. Cool. Now what's happening over here in /23? We are borrowing the first 7 bits that we have. So the first 7 bits are going to be these, right? And we are turning them on with 1, 1, 1, 1, 1, 1. Correct? So instead of having all the 8 bits dedicated for host portion, you just have now this, I would say you just have now this particular bit as host, and it has been converted. The first 7 bits has been converted into network, and we will call these 7 bits as borrowed. So when we talk about the formula that we have, when we talk about the formula that is for network, we specify 2 to the power 7, correct? Because these are the 7 bits that are on. And then the answer is 128 networks. Cool. Then for hosts, we specify a number of off bits. How many bits are going to be off over here? You can just connect to single router with multiple networks. That's fine. How many host bits are here? It's not just one. It's collection of all these bits. That's 8 bits, 1 bit from the third octet and 8 bits from the last octet. That makes it 9. So that's why the number of hosts is going to have the value as 512, because 2 to the power 9 is 512. It means that you are going to have 128 networks, and in each network you are going to have 512 IP address, out of which usable will be 510. Now pay your attention, as class B, understanding this part of subnetting is very crucial. Okay, so do you understand how did we come up with number of network and number of host? So again we will talk about how did we come up with this information. /23 as the example. So if I write down about /23, I can say that it's 1, 1, 1, 1, 1, 1, 1, because class B has a network prefix of N, N, H, and H. Means two octets are dedicated for network and 2 octet for host. That's why I'll write the 2 octet as 1111 in black. It means that we cannot do anything over here. Cool. So I'll say 1, 1, 1, 1, 1, 1, 1, 1, and another set of 1. So this is all reserved for default network prefix. Then by default, we have everything dedicated for host. So the first 8 bits and the last 8 bits. These are the host and these are the host. What do we do is, as we need slash 23 over here, as we need slash 23 over here, we just specify the first 16 bits and then we add plus 7 bits from the host portion. And that's how we come up with the slash 23 binary value. So the value will now change and it will remove the first 7 bits, okay, from the third octet, and it will add its own 7 bits. Do you understand that? And then the last bit will be the 0 and then dot and then everything will be 0. So this is staying the same. You just got one off bit over here. And then the remaining thing that is over here is going to be n. And this n is nothing but borrowed from host. That's why we say number of networks is equal to 2 to the power 7. That says 128 network. Now talking about host, host is nothing but all the off bits that you have in your binary conversion. So how many bits do you have in subnetting? You have subnet mask is made up of 32 bits, right? Minus how many bits did you dedicate to the network prefix? 23, correct? How many bits are left? 9. These 9 bits will be what? Hosts. This is as simple as that. So then you specify these 9 bits as number of hosts, that says 2 to the power 9, and you get a value of 512. Do you understand that now? All right. Then we will move ahead towards figuring out the subnet mask. And the subnet mask is going to be the dotted decimal conversion of this binary value. That's how many bits do you have? 23, correct? So for the first 8 bits, it's going to be 255. For the second 8 bits, it's going to be 255. For the third octet, now how many bits are these? 8 plus 8. How many bits do you need? 7. So you need to put down the 7 bits into the master formula, which would be the addition of these. Okay, and the addition of these would be 254. Cool. Do you understand that? It will be the addition of 128, 64, 32, 16, 8, 4, 2, and 8, 4, and 2. And the addition of this will be 254. I hope you understand that. That's how you come up with 254, and then the last octet will be 0. Perfect. Now we will move ahead to the most important part of Class B subnetting, is figuring out how block size would be made. Okay, so the block size will of course start at 172.16.0.0. Cool. And this is N, this is N, this is H, and this is H. So we can play and make changes into last 2 octet. If we talk about this address, which is 192.168.1.0, the first, second, and third is N. That's why we can only make changes into the last octet. But in Class B, you can make changes into the third octet and fourth octet as well, as they belong to the host prefix. So we will start at 192.172.16.0.0, and where would we end? We would end up at 172.16.0.255. Correct? That's how we usually end. Make sense? And how many IP addresses are these? 256 IP addresses. And what would be the second network? The second network will start with 172.16, and then we can make changes to the third octet. So as 0 is complete, okay, we took down everything from 0. So from 0.0 to 0.255 we are done. Now the third octet will change to 1.0 to 172.16.1.255. Have you seen your meter, or I would say kilometer reading in your, or miles reading in your car, right? The speedometer. It says by default when you purchase it, it shows 0.00000. Correct? And then it as you drive your car, it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this value becomes 1, and then this particular thing again repeats, and then you will see 2 over here, and then second iteration and 3 over here, third iteration 4 over here. So this is how it becomes 11, 12, 13, and then 21, 22, 23, and then 31, 32, 33, right? So as the last octet fills it up, then the changes happen at the third octet, or the second last octet, I would say. Just like that, over here as well, if you can relate to it, the third octet got filled. It cannot go to like 200 and like can we say that instead of writing it like this, can as we need 512 IP address in one network, can we write it like 172.16.0.0 to 172.16.0.511? Can we write it like this? We cannot write it like this, right? Because the maximum value that we can have in an octet can only be 255. So that's what we are saying. We will write down the last value as 255. And then this is just 256 IP address. But what we need another 256 IP address. So what we do, we say the next network is 172.16.0.0. Okay, but we cannot start with 0.0 again. We gotta start with 1.0 now. And then we're gonna end up at 172.16.1.255. And what is this? This is another 256 IP address. So you can say that you got these 256 and you got these 256. When you put them together or add them together, what's gonna be the output? 512. Do you understand what I just did mention over here? We've got this first network and we've got this second network, and each network gives you 256 IP address. If we merge those two segments of 256 IP addresses together, can we get an entire block of 512 IP addresses? Do you agree with me that we need 512 IP addresses? So if we take a network of 256 IP addresses, which is 0.0 and ends up at 0.255, and then we take another network of 256 IP address, and that will again be another 256 IP. So, and if we merge, or I would say make these two networks or two segments as one network, okay, will it be possible that this can become a network? Because see, I can say that we start at 0.0 and we end up at 1.255. So we are kind of merging two different segments of 256 IP addresses and merging them into one. So we can say that the first network starts at 172.16.0.0 and it ends up at 172.16.1.255. Do you understand that? How many network bits do we have? We have two network bits, that is this and that is this, that is this and this. Did we make any change into this? We didn't change either 172, we didn't change either 16. Both the octets are same. That's why people can communicate when both the octets are same over there. So what we do over here is whenever the number of hosts crosses its limits and it becomes 512, we need to merge different segments, okay, of 256 and add it. That's what we do. And then this will be the first network of the 128 networks that you have got. So what will be the second network? The second network will be another merger of another two segments of 256 IPs. So it starts at 172.160, sorry, 16.2.0 now, because 0.0 and 1.0 are both of them are used. And then we start at 2.0 and we end up at 172.16.3.255. Another two segments are merged over here. Do you understand that? And the third segment would be 172.16.4.0, and we will end up at 172.16.1.255. 192.16.5.255. That's what the thing is. So in each network, you've got 512 IP address, 512 IP address, and 512 IP address. And you are going to have 128 such networks, okay, each having 512 IP address. So you can imagine how bigger of a network that can make. That's why we say Class C is used for smaller network, Class B is used for medium-sized network, and Class A is used for larger size networks. Do you understand that? Now, there is just one logic that you need to understand over here, that we are saying that how many segments do we actually merge? How do you get to know that? Okay, because over here it's easy to calculate that 256 and 256 makes 512. But let's say you gotta figure out that for a 16,386 host size, how many segments do you merge? So for that there is a logic. Now, do you understood how did this slash 23 work? I can explain you that logic in slash 22. Both the IP would be different. Yes, both the IPs would be of different network, meaning that this network cannot talk with the other network. That's not possible. But people, these 512 people or 510 people who are connected there can communicate together. Okay? And what's going to happen? This is going to be your network ID now. And this is going to be your broadcast ID for the third network. Cool? If we say that in this network we merge two networks, right? 172.16.4.0 and it ends up at 172.16.4.255. And then we again merge 172.16.5.0 and 172.16.5.255. Earlier, this also was network ID and this also was network ID. And this was broadcast and this was broadcast in Class C. But now, if we just talk about current scenario, only 4.0 is network ID and only 5.255 is broadcast ID. The 4.255 and 5.0 will be normal IP addresses and they will be usable and they can be assigned to any, I would say, host there. So that's what needs to be considered over here. Are we good? Do you understand this slash 23 example? All right, so let's keep this example over here and move with the next example in which we can see that how would it get clearer even more. So the next example that we can take is 172.16.0.0 and let's do it for slash 22. Cool, we will just see how this can be done for slash 22 and we will first convert it into binary as the drill continues and we'll say 1111111 and over here we are going to have 16 plus 8, that makes 24, so we don't need 8 bits. 16 plus 6 makes 22, so we need to borrow 6 bits, correct? So we'll say 1 2 3 4 5 6 and then we will add the remaining 2 to complete the octet and then we have another 8 bits as the host. And this continues to be network. Good. So we specify the master formula over here as well, 128, 64, 32, 16, 8, 4, 2, and 1. And that gives us that let's configure number of network, that is going to be 2 to the power 6, as 6 are the number of borrowed bits and we say 64. And the number of host is going to be 2 to the power 10 now because you have 2 plus 8. Correct? It's going to be 10. And then you say 2 to the power 10 is 1024. And then you specify subnet mask is going to be something like 255.255 dot. How many bits do you need to add now? 6 bits. So we say 128, 64, 32, 16, 8, and 4. That basically makes it as 252. And then we say dot 0. If you add the first 6 bits from the master formula, it's going to be 252. Do you understand that? And then talking about the block size. We start at 172.16.0.0 of course. But now how many segments of 254 needs to be merged? So we say now there is a logic that whenever the number of hosts gives you a value that is greater than 256. Understand this logic pretty well. Whenever the number of hosts is greater than 256, divide it by 256 in order to fetch out the number of segments that you need to merge. So if I divide it by 256, you get an answer of 4. That means 4 segments need to be merged, which means if you start at 0, then 0, 1, 2, and 3. These would be the 4 segments. So what it means that if we start at 0.0, we end up at 172.16.0.255. That will be the first segment. The second segment is going to be 1.0 to 172.16.1.255. The third segment is going to be 172.16.2.0 to 172.16.2.255. The third one is going to be 172.16.3.0 to 172.16.3.255. Correct? These are going to be 1, 2, 3, and 4. 4 segments. So this one becomes our network ID, and this one becomes our broadcast ID. And totally combine them, these are 1024 IP address, as 256 multiplied by 4 is 1024. Do you understand that? So the first network for this particular thing, for this block size, is going to be 172.16.0.0, and it's going to end up at 172.16.3.255. The next network, the second network out of the 64 networks that you're going to have, is 172.16.4.0, and it's going to end up at 172.16.7.255. Do you understand that? Perfect. The third network is going to be 172.16.8.0, and it's going to end up at 172.16.11.255. And you will have the 64th network will look like 172.16.252.0, and it will end up at 172.16.255.255. That's what the last network will look like. These will be 64 networks and 1024 hosts per network, out of which 1022 will be usable. I hope you understand that thing. Perfect. So that's kind of an example that we can take for class B. The last part is the IP address. I would say the 64th network. So it's gonna be like just like that. You're gonna have 64 networks, and the 64th network will start from 172.16.252.0, correct? And then it's gonna end at 172.16.255.255. Cool. And you're gonna have 64 networks like that, and 1024 hosts per network, out of which 1022 will be usable. I hope you understand these two examples of Class B. All right, that wraps our first section of the class. Let's have a break for 10 to 15 minutes and then we will resume. So you can practice at home for 172.16.0.0 slash 21, okay, slash 20 slash 19 slash 18 slash 17. These are going to be your homework, I would say. And then we are moving ahead towards Class A Subnetting. Cool. And in this particular Class A Subnetting, we're going to take an IP, and the range for that is going to be /8 to /15. So makes sense that we'll be making the modification into second octet over here. So we will talk about an IP address or a network that would be from class A, that's 10.0.0.0. And then we will do the subnetting for /15. Cool. So we got to figure out first thing as number of network. Then the second thing is going to be number of hosts. The third thing would be subnet mask as always. And the fourth thing is going to be ranges, or you would say block size of that. So as the drill continues, the first thing is we write down the /15 parameter into binary. So we say 1 1 1 1 1 1 1. That first 8 bits are going to be about network. As class A uses a scheme of NHHH. So you get 24 bits as hosts, okay, and 8 bits as networks. So these 8 bits are going to be dedicated for network, and then we will move ahead and say the next 7 bits are going to be dedicated as borrowed bits, borrowed network bits, and then there will be a last bit that would be 0 from the second octet, and then everything apart from that will be 0. Do you understand that? Perfect. Just like we saw in class B, you would have a default network range that is going to be this. Then you are going to have the borrowed bits. These are going to be the 7 borrowed bits. As you are working with /15, the breakup of /15 works like /8, which is going to be default, and we will borrow /7 as I would say borrowed. That's how we come up with /15. Okay. So these 8 bits are going to be our default bits, and these 7 bits are going to be our borrowed bits. As we are going to have default schema of H, the last 3 octets are going to be host prefix. Makes sense? So that's why we're going to have the first 7 bits as borrowed bits and the remaining bits as the host bits. So moving further with that, how are we going to have our number of network? The number of network would be 2 to the power 7. That's 128 again. And then for number of hosts, you can say how many hosts do we have now over here? How many bits do we have dedicated for host? We have this 8 bits. We have the last 8 bits that makes it 16, and plus this 1 bit from the second octet, that's 17. So we say 2 to the power 17 as number of hosts. And what's the value of 2 to the power 17? It's 131,072. That's what 2 to the power 17 makes. You can Google it or you can use your calculator. Cool. It's 131,072. And then how do we come up with subnet mask? It's going to be 255 dot. These are the 8 bits. Plus we need to add 7 bits from the master formula that we have. That's 128, 64, 32, 16, 8, 4, 2, and 1. That's going to be first, I would say 7 bit again makes it 252. So we'll say 254.0.0. The first 7 bits and adding them together makes it 254. So that's what the subnet mask will be. Okay. And then talking about ranges, it's going to start at 10.0.0.0. And how many again we need to merge certain segments over here. And the modification is going to be done over here, not on the third octet anymore. So when you do modification, so when you do class C subnetting, the modification is done at last octet. When you do class B subnetting, the modification is done at the third octet. And when you do modification at, when you do subnetting for class A, you do modification at second octet. That's how it works over here. Cool. So I say 10.0.0.0. And then how many segments do we need to merge? We need to divide it by 256. And when you divide it by 256, the answer is still going to come as 512. Am I correct? If anyone is doing it through calculator. If I divide 131,072, which is 2 to the power 17, by 256, the answer comes at as 512. Now you see the value is still bigger than 256. And our rule is until unless you get a host value that is less than 256, just keep it dividing. So we will again divide this result with 256 and you will get an answer as 2. So as the division is happening for twice, that's why if no division is happening, this is where we make the changes. If division is happening for once, we shift it from last to third. And if division is happening for second, then we shift it 2 times. And we do the modifications over here on the second octet. Do you understand that? So we are going to start from 10.0.0.0 and we reach at 10.1.255.255. You see that? As we are dividing it for twice, okay, the change that the addition of the segment is going to affect at the second octet, 0 and 1. In class B, we only did make the change for once. That's why we made the changes at third octet. Okay, we used to say that 172.16.0.0, and then we stopped at 172.16.1.255. So this is where we made the change into the third octet. But over here, this is we just have one network prefix, and everything is host, host, and host. So this is where we need to make the change on the third octet. Make sense? The next network out of this 128 networks will be starting at 10.2.0.0 and ending at 10.3.255.255. And then the next network will be 10.4.0.0 and 10.5.255.255. You get that? And in each network, you get 131,072 IP address, out of which 131,070 IP address are valid, because this will be the network ID and this will be the broadcast ID. You get that? Cool. So that's how you do class A subnetting. We will, yeah, what I said is just the first IP is going to be network ID and the last IP is going to be broadcast ID. Then we will have another example of class A subnetting. Let's say 10.0.0.0, or I would just write it in black and say 10.0.0.0 slash 14. Let's go for 14 now. And we'll just move it with by like writing the binary function. That's 111111111. And then 4 bits is 8 plus 6, that makes it 14, correct? So we add another 6 bits that will be as borrowed bits, and the remaining 2 bits will be as host, and then we again have that acts as our. So this is going to be network, this is going to be borrowed, and that's going to be host, correct? And the master again 128 64 32 16 8 4 2 and 1. So the things that we got to figure out is number of network. The second thing that we got to figure out is number of host. The third thing that we got to figure out is subnet mask. And the fourth thing that we figure out is ranges. Cool. So the network is going to be 2 to the power 6, as we have 6 borrowed bits, and it's going to be 64. The host is going to be 2 to the power 18, and that can anyone tell me what the value would be? 2 to the power 18. That's 262,144. Cool. The subnet mask is going to be 255 dot. We need to add 6 digits from the master. That's 128, 64, 32, 16, 8, and 4. And that makes an addition of 252.0.0. Cool. And then the ranges is going to start, of course, from 10.0.0.0. And how far are we going to go? We'll just divide this value with slash 256, and you will get a result of 1024. Cool. And as the value is still greater, we will again divide it by 256 and the answer will become 4. It means that we need to merge 4 segments together. And we start at 10.0.0.0 and we end at 10.0, 1, 2, and 3. These are going to be our 4 segments. So we end up at 10.3.255.255. That's the first network of our 64 networks. And then for the second network, we start at 10.4.0.0 and we end up at 10.7.255.255. For the third network, we start at 10.8.0.0 and we end up at 10.11.255.255. And for the very last network, for 64th network, we will start at 10.252.0.0 and we will end up at 10.255.255.255. Make sense? This, and this. Everything is going to be network ID. And this, and this. Everything is going to be broadcast ID. And every IP address between that is going to be a valid IP address that can be assigned to any host that gets connected over your internet. Do you understand that? That's how it exactly works. Perfect. And then we can, so what you need to do for me is for class B, you need to do from slash 20 sorry, from slash 17 to slash 21. You need to do this as homework. And for class A, you need to do slash 9 to slash 13. That's your homework. So these are the subnetting things that you need to do for me, okay, as part of your assignment. And then we are pretty good with subnetting, okay. That's not three difference, Adi. That's four differences, including zero. We say 0, 1, 2, and 3. That's four. We start from 4. That means 4, 5, 6, and 7. Okay. Then 8, 9, 10, and 11. 252, 253, 254, 255. That's how five things works over there. Sorry, that's how four segments are merged together and forms up a network that gives you around 262,144 IP addresses in one network. Perfect. So that wraps our theoretical thing. Okay. And from next class, we are going to install our Cisco packet tracer on our local devices, and then we're going to implement the labs. So from next class, we are going to get familiar with Cisco's very own operating system. We're going to talk about how devices works there. We're going to talk about how IP addresses and subnets can be configured. And then we are going to move ahead with small understanding knowledge about how broadcast domain works, what are the differences between switches and routers and hubs. Okay. Yeah, we will be talking about Cisco Packet Tracer installation as well. Okay, I'll walk you through that. We are not going to do GNS3 lab as of now because it will kind of increase the complexity into the class as we have so many participants. But I'll drop the links of some reference material that you can take help of in order to install GNS3. But for the lab purposes of our class, we are just going to do it by using Cisco Packet Tracer. That'll be helpful for us. Cool. So as we are wrapping up quite early over here, but we are good with the concept that we have, and we'll start with the labs with the fresh class that we can take. So I hope you enjoyed the session today. Okay, that we talked about Class B and Class C subnetting, and do keep practicing this particular thing because the more you practice about subnetting, the better it will be for you in order to be able to implement it in the production environment. Thank you so much for joining in today. Okay, and I'll see you guys same time. Okay, with the same atmosphere and same energy from you guys as well.